Okay, so in this video, I want to explain to you where the idea for perpendicular lines comes from and why we can identify the gradient of a perpendicular line using what we refer to as the negative reciprocal. So this is quite a challenging thing to describe from the outset, because we can go straight in with, oh well, a line has so in this video I want to introduce you to perpendicular lines. Okay, so if you've got a line, let's say this here, okay, and we can call this line L, then a perpendicular line, so let's draw that in, would be a line like this, and we could call this line, let's call that L1 and this one L2, okay? And they are perpendicular because the point of intersection makes a right angle, okay? So this is a right angle. Now, if I know what the gradient of line L1 is, how do I work out the gradient of L2? Okay, and that's using something referred to as the negative reciprocal, and that's really what we want to derive here. So can I try and explain where that comes from? Because it does feel like a little bit of a leap of logic, and to do this we're going to try and derive it geometrically. So the way to do this is I'm going to draw a horizontal line. So a horizontal line going through that point of intersection. So here's my horizontal line. Okay, and then I'm just going to drop a perpendicular down. So I need that line to be a little bit longer. So just a little bit longer, and then I'm going to drop that perpendicular down to construct a right angled triangle here. And I'm going to do the same over here as well. Okay, and I'm going to construct another right angled triangle. So, now these two right angled triangles, you can see, are not the same sides. Okay, they could be if I'd managed to get a gradient of 1, then actually these two triangles would have been exactly the same size. But because I didn't draw one of exactly 1, they're looking slightly different. Okay, but also, you know, that length might not be the same as that length, although they're quite similar. But beside the point, okay? Now, let's label some points. So let's call this point point A, and this one point B, and let's call this one point C, and let's call this one point D, and this one point E. Okay? Now, the gradient of my first line, L1, so the gradient of L1 is equal to, well, that is found by getting your difference in the y coordinates and dividing that by the difference in the x coordinates. So actually that is the length AB, and dividing that by that length BC. Okay, so the vertical difference divided by the horizontal difference. And I could also write down what the gradient of L2 is as well. So the gradient of L2 is equal to Well, that's the difference in the y-coordinates, so DE, divided by the difference in the x-coordinates, CD. But assuming that those lengths, because we're looking at lengths here, these are positive, this is a negative slope, so it will have a negative gradient. So I'm going to pop a minus sign out the front. Okay? Right. Now, the next thing to consider is, right, so I've called this point 7. I'm just going to relabel it so it's there. This would also be a right angle. So, because your lines are still perpendicular here, right? So if that's a right angle, then what I can do is I can say, right, let's call this length, this angle rather, x. And I could call this angle y. Now, if I do that, then I know that this angle here, okay, because of these three angles having to add up to 180, I know that x plus y, if I subtract 90 from both sides, must be equal to 90. Now this angle here, because we've got 90 there already, these two have to add up to 90 as well. And if these two add up to 90, then this angle must be the same as y. And likewise, these two angles must add up to 90. And so this angle must be x. Okay, so those two angles are the same, and those two angles are the same. Okay? Now, because you've got these two right-angled triangles, and they both have an x angle, they both got a y angle, these are similar triangles. Okay? So they're similar triangles because they have the same interior angles, but they just have different length sides. So it's kind of like this one is a slightly smaller version of this same triangle. Okay, it's just been shrunk inwards. But that is saying actually that the ratio of the sides would be the same. Okay, so if we think of it like this, we can say, well, the angle that is opposite the x here is AB, and the side that is opposite the angle y here is BC. Okay, that ratio of side lengths must be the same as the side that is opposite the x here, CD, divided by the length that is opposite the y here, the DE. So these have to be the same because of them being similar triangles. But where have I seen this before? Well, the AB over BC is the gradient of L1. And what you've got here is actually very similar to what we've got here. This is equal to, well, because we've got the fractions round the other way, we've actually got the reciprocal of the fraction, haven't we? So the reciprocal of this is this. So we've actually got 1 over the DE over CD that I've got there, because 1 over will flip the fraction round and be a reciprocal. And I've got the negative of that value. So these two minuses would knock each other out, and then 1 over would flip that fraction round. And so CD over DE is equal to this, which means that AB over BC must be equal to this. Okay? So what does that mean? Because this is a lot of letters going on here. let's make this simpler. If the gradient of L1 is that, let's call that M1. And if the gradient of L2 is this, let's call that M2. So actually what I've got here is, if I get rid of that middle bit now, okay, the AB over BC is the gradient of the first line of L1, and the minus DE over CD is the gradient of line 2. So actually, two lines are perpendicular if the gradient of one is the negative reciprocal of the other. And if you multiply both sides, so let's just bring that together a little bit, because it's a bit far apart there, isn't it? Minus 1 over M2. What that means is that if you multiply both sides by the M2, we get that M1 times M2 must be minus 1. So if you have your two gradients, if they multiply together to make minus 1, then the two lines must be perpendicular. Okay? So that is how we get to this state of affairs here. Okay? So let's move away from the proof part, okay, and let's get down to what we need to know here, okay. So if line L1 has equation y equals m1x plus c1, and line L2 has equation y equals m2x plus c2, then they are perpendicular if m1 is equal to minus 1 over m2, okay, i.e. m1 times m2 is equal to minus 1. So what we're looking for here is what we refer to as the negative reciprocal. So if I wanted the negative reciprocal of 3, so the negative reciprocal of 3, well, that is minus 1/3. So if I wanted to find an equation that was perpendicular to y equals 3x plus 2, then y equals minus 1/3 x, take away 5, is perpendicular to it. It's based on the two gradients. So if the gradients are negative reciprocals of one another, then I know that I've got perpendicular lines. The negative reciprocal of minus 5 would be 1 over 5, because that is the same as minus 1 over minus 5. Okay, so it would be like writing minus 1 over minus 5. And so that's your 1/5. So essentially you're changing the sign and finding the reciprocal. So if it was, let's say, minus 2/3, the negative reciprocal minus 2/3, you change the sign and flip the fraction. Okay? And so this is how we can identify perpendicular lines.